All right, so here we are again, solving yet another set of digital SAT math problems. So this time we're using some practice questions from Bluebook. So, like you, I don't know what to expect, so just accompany me. Try to solve this on your own, and then um, just listen or just check this video every now and then if you're feeling stuck on a specific problem. So let's go ahead and solve some of these questions. The goal is to finish questions 87 up until 96 or whenever Zoom allows me, because I think I only have 45 minutes. So hopefully we're done even before then. Ideally, we should be done, right? Okay, make sure you have your calculator with you. And then if you have your decimals, pull it up already in case we need it. Okay, let me just make my face smaller. There we go. And then I'll just activate my pencil. Okay, so let's do question 87A. So this is already in the second module part. So let's go ahead and try this out. So total cost FX in dollars to lease a car for 36 months. So keep that in mind. What is happening with the pen? Okay. And then from a particular car dealership, and then we have this expression for f of x. Give me a second. Let me just modify my pencil. Okay, there we go. It should be thicker. I like it this way. Okay, next. Okay. Let me just see if I can close it out. Okay, perfect. Okay, sorry about that. And then, what is the total cost to lease a car when the monthly payment is $400? So, we have 36 months here and then monthly payment of 400. This one is actually straightforward. We have x is equal to 400 and then the goal is to find f of 4. So all you have to do is to plug in these values. So 36 times 400 plus 1000, right? Just make sure you key in the correct values. So with this one, you can already, at this point, you can pull out your calculator. But I know 36 times 4 is 144. And then adding this up, it should give us 15,000. Don't worry, both modules and all sections of the digital SAT allows you to use your calculator, so you should be fine. So our answer for this number is C, and we can go ahead and double check. Okay, what is the answer A? Oh, we're looking at the wrong answer key. Okay, we have C. All right, that's me and my Um, sometimes I don't trust myself, as you can see. So, obviously it was the right answer, but I had to, just double check if I actually got it right. All right, let's do 88. So we have g of x when x is 8. So this is pretty much straightforward, right? All you have to do is to plug in 8 into x, and this one gives us 80, correct? And then we have 8. So that's 88 for us. All right. So that's D. Let's go ahead and double check this part. So we got D. All right. Next one. So sometimes you might have to enter your values. Even if you took the pen and paper SAT already, this is not new to you, right? There are instances in the SAT where you have to enter your values just to make sure that you are using the correct format. And we are given two parallel lines, G and K, with a transversal line of T, and the goal is to find X, right? And we know that these two, they form linear pairs, so meaning they add up to 180. So all you have to do is to subtract 180 and 133, and that will give you the value of x, and that's 47 degrees, right? So all we have to do is to write the numbers, make sure you review this section, and write your answers in the correct format. So let's double check. All right, perfect. We got 47 for this number, and then let's proceed. Okay, so as you can see, as we progress throughout the module, it becomes more challenging. And then the next module, it should actually be more difficult. Okay, so we have a graph of 7x plus 2y is equal to negative 31. And then we have an intercept here at A and then a y-intercept at B. Okay, this is interesting because with decimals, this is going to be easy. If you have a graphing calculator, it might come in handy in finding A and B, but I'll show you first the algebraic approach only because I want you to understand the concept, right? So we have x here. X-intercept, it tells us the value of x when y is equal to 0. So meaning we have 7x plus 0 is equal to negative 31. So x is just equal to negative 31 all over 7. Similarly, if we apply this for the y-intercept, this happens when x is 0, and the y-intercept is the value of y at that value when x is 0. Meaning this is equal to A, and then this is equal to B. So if you're looking for B over A, and then all you have to do is to write this way, right? Negative B all over A, negative 7, and then that gives us negative 31 over 2, 7 over 2, correct? Okay, perfect. And we can also use decimals. Let me just pull up my decimals kit quickly, and then I will be back. I'm back on my recording, and I've already pulled up my decimals, and as you can see, I've already keyed in the equation. So that's 7x plus 2y is equal to negative 31. And then what's the goal? The goal is to find the intercepts here. Unfortunately for us, for decimals here, it just gives us like a round off number, but this will still help, right? Because we're looking for B over A, where B is a y-intercept. So it's just a round up number, so that's negative 15.5 divided by, as you can see, because remember A is 31 over 7, so we're not expecting good numbers for our y-intercept. So we get negative 15.5. And then all you have to do is to divide, and then it should give you a close round-up value. So that's roughly 3.499. And our option shows us 7 over 2. So that's 3.5. So meaning you can also solve this quickly with decimals, right? And then just find the closest value in the choices that should be the correct value. If you're given a value like this, but if it's a good number, then you should get the exact value as well when you're using decimals. All right, but the good thing is you have two options. You can do this algebraically, it's just fast anyway, or you can also type in and use decimals to solve this problem. This is why it's very important that during your SAT prep, you are also practicing using decimals so that you know intuitively when to use it and when not to use it. It really depends on you as a user. And we can double check our answer. We got D for number 90 here, right? And let's continue with 1918. Okay. An object travels at a constant speed of 12 centimeters per second. We have this. And then we're looking for the time it takes it to cover 108 centimeters. This is pretty much straightforward. If you've already taken physics or even basic science classes in middle school, you might be familiar with this table, right? And we really know that this time is just distance over speed. So basically divide it to and use your calculator for this. Okay, I wrote the values already. Sometimes it happens. And we have 108 over 12, which gives us 9. And that helps. And I'm also telling you that although there is a calculator available, it really helps if you've honed your arithmetic skill at this point because it gives you an edge, right? For example, right off the bat, um, I knew right away that 108 over 12 is 9, and it helps because all I have to do in the calculator is just double check if I'm feeling doubtful of myself. And that is the advantage of making sure you're still practicing your arithmetic skills, even if these tools are already available. All right, and let's double check. We got 91 here as A. Let's continue. 92. Okay, what do we have? So John paid a total of 165 for a microscope by making a down payment of 37 plus P monthly payments of $16 each, right? So meaning John already paid $37 and then we have to pay $16 every month for P months. And this should add up to the total amount of the microscope. And this is your equation. What do we have? So we can just rewrite things here until we end up with something in the choices. Or you can just spot check which terms are matching and we can see that this one is C. And let's double check our answer. We have C here. All right, perfect. Okay, let's continue with D, 93. The answer is D for 93, and let's figure out why. Okay, so the table shows three values of X and their corresponding values of Y. There is a linear relationship, so this is important. And what do we know about linear relationships? We have two equations, very essential equations. Y is equal to mx plus b. And we also have a point slope form. Y minus y sub 1 is equal to x minus x sub 1. All right, and why is this important? Because we have a linear relationship, and if we want an equation that represents this relationship, then we might need either of the two. When is the first equation helpful? If you have the y-intercept and you have the slope. So if you have a y-intercept right off the bat, use this option. But if you're only given a point, then use this already. Oh no, I clicked something. Hold on. Oopsie. Oh no. Okay. When you're given a point, use a second option. So let's inspect. First, let's go ahead and figure out the slope. And what is the slopes formula? Y sub 2. So this is just basically the change in y and the change in x, right? So meaning as long as you take the difference between y and then over x as well, you should be fine. Just make sure you use the corresponding points in the same order. For example, let's see, focus on 0, 18, the endpoints, 2, 8. So we have 18 minus 8 all over 0 minus 2, and that's giving us negative 5, right? So we know that the slope is negative 5. What else do we know? We know that the y-intercept is 18. And why is that? We have x here equal to 0, and then y is equal to 18. Remember, the y-intercept is the value of y when x is equal to 0, meaning we have m, we also have b, So the first equation is the most helpful equation for our problem. And the final equation should be negative 5x. All you have to do is to replace m here and b here plus 18. And this is why the correct answer for 93 is D. All right. If you need more sample problems like this involving linear relationships, then let me know. I can go ahead and pull up and create more for you and help you get through different types of equations like this. Or any topics in math, actually, just let me know. All right, 94. Okay, an object is kicked from a platform. The equation h is equal to 4.9 t squared plus 70 plus 9. Okay, so we know it's a quadratic equation, and if it's a quadratic equation, it is a parabola. So sometimes it helps, right? By knowing your functions, knowing how the functions looks like, it helps you imagine what this looks like. Okay. Leading coefficient is negative, so we're looking at a parabola that opens downward. Okay, let's continue. Represents the situation, blah, 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 where h is the height of the object above the ground in meters, t seconds after it is kicked. Which number represents the height in meters from which the object was kicked? Oh, okay, interesting. Okay, which number represents the height from which the object was kicked? Okay, so this is interesting. We apparently don't have to find anything. We just need to inspect and understand what the graph tells us, right? And you can also graph this on decimals. Why don't we go ahead and do that? 4.9 x squared. I'm just changing this to x out of me getting used to working with x when I'm graphing. Okay. So what does, obviously this part, okay, we have this one here, right? So which number represents the height in meters from which the object was kicked? So meaning it is telling us, because if you have a height here, let's say, let's draw a cliff. And then you're kicking a ball from here. Where are you starting from? You are starting from the height of this cliff, right? So meaning at t is equal to 0, what is your height? And that's what this intercept is telling us, right? When x is equal to 0 or when t is equal to 0, the original height is 9 meters. So the number that we're looking for is actually 9 because it tells us the original height or the y-intercept. So we're looking for the y-intercept for problems like this. And this is why D is the correct answer. And we can double check. 94 is D, correct. All right. Let's continue with 95. Okay. Which table gives 3 values of x and their corresponding values of h of x for the given expression? Okay, let me just pull up my decimals and experiment with something before I share it with you. I'll be back. I just confirmed something before I actually walk you through it. All right, so there are 2 ways to solve this, okay? Number 1, algebraically. Number 2, decimals. For this problem, I would recommend using decimals only because it's going to save a lot of your time. But what we can do first is spot check. So we have all of these tables. It's telling us x is equal to 1. We're just comparing the values of these 3 values of x. So we can just go ahead and evaluate. So 1 squared minus 3, that is just negative 2. 1 squared minus 2 squared minus 3, that's just 1. 3 squared minus 3, that is just 6. Right? And then as you can see, B should be the correct answer. And then why is it that I took a break to show you this on decimals? I want you to try this. Just key this in, type in the equation, and then from here, click on settings and then create table, right? Of course, we only have from -2 to 2 by default, but you can just add the value of 3 and focus on this 1, 2, and 3. -2, 1, and 6. And it's showing us the same set of values. Obviously, they are the same functions, so we're expecting the same values. And without even calculating and making sure that we avoid any arithmetic mistake, then this is really a safe approach when solving this problem. All right. Let's continue with question number 96. All right. In the linear function, f is equal to 0, 8, f is 1, and then we're looking for the equation. So sometimes this might look confusing or we're not sure what to do, but always remember linear function. And then when you have a linear function, remember the two equations I've mentioned earlier. That's what you'll probably need to find the equation, right? So this looks a little bit intimidating or unfamiliar because it's written this way. So why don't we use write them in coordinate form? So this tells us that when x is 0, y is 8, and then if x is 1, y is 12. And then we can celebrate. What we're given here is a y-intercept. So good for us. We can use this equation, right? The standard, the slope-intercept form. And we have b now. So meaning we just need the slope. And remember, slope is just equal to the difference or the change in y over the change in x, or y sub 2 minus y sub 1, basically the difference between two y coordinates, and then in the same order, the difference between their corresponding x coordinates. You can switch the numbers around just to make sure that whichever order you actually use in the numerator, you apply that in the denominator as well. Okay, so this is a good reminder on my screen, okay? So if you're studying, I would recommend using Pomodoro timer. This is what this is about, so that you could take a break for 5 minutes, keep your focus back, and make sure that you move around, and that's what the reminder is for. Okay, so let's go ahead and apply our formula here. 12, 1 minus 0, so we have 4. Correct, 4. Okay, so we have m now, which is equal to 4, and then we also have b. So meaning our final equation is 4x plus 8, because our b is equal to 8, and that is letter D. Okay, so this module apparently loves linear functions so much. So hopefully the next one that we're working on, the next set, we could work with different other equations. Okay. So we have this equation, multiple variables. Whenever you spot something like this, chances are this is a literal equation that you need to solve. So which equation correctly expresses k in terms of j and m? Exactly, right? So the goal is to isolate k on one side and then move all the terms around on the other side. So we normally start with, isolate the variable on the left-hand side and then move all the other variables on the right-hand side. So let's go ahead and do that for our equation. So 14j plus 5k is equal to m. So isolate 5k here, that gives us m minus 14j. And then for us to isolate k, we have to divide 5 on both sides. And then take a step back, review your choices, and then see which one makes sense. Do we separate the terms or do we just leave it as it is, right? And from here, we can see that k is just equal to m minus 14j over 5. I didn't have to divide each term by 5 because I already saw this choice. So I could have stopped here, right? And then spot check. Oh, okay, my answer is already there. That's probably the correct one. And we can double check. In fact, 97 is indeed 8. Okay, last one for this video. Okay, this might be interesting. Finally, a geometry problem. Okay, and also if you want more geometry or trig problems, I have another video for that. You can go ahead and check that out. Okay, the side lengths of right triangle RST are given. Okay, is similar to triangle UVW. So you make sure that whenever you construct two similar triangles, you have to make sure that they correspond correctly, the vertices. Good thing that the problem ensures this for us. So R is corresponding S corresponds to V. So that's why I wrote it here. And then T corresponds with W. So the remaining one corresponds with the other. All right. And then we're given RS is 440. ST is 384. And then TR is 584. So what do we know about similar triangles? They are proportional, right? The ratios of the triangles should be the same. And we are looking for tangent double. Okay, let me just check something quickly. So, okay. All right, we're looking for tangent W here, and these are what we're given. So we're expecting, since this is tangent W, let me redraw our triangle to a right triangle, right? And then the longest side is TR, so that should be the hypotenuse. Does that make sense? Okay, and so what I did, I went ahead and double checked to see if this these values satisfy the Pythagorean theorem. So that's what I was doing. So you can also go ahead and do that. So we have 384. So why is it that I took a pause and realized, oh, I'm working with a right triangle? Because we're looking for tangent W. And for this to work, the two triangles should be a right triangle. Okay. Anyway, for the context of SAT, okay? So let's rearrange this WU and then V. All right, good. So remember, the proportions are the same. So let's go ahead and see tangent W. This should be related to tangent T, correct? And what is tangent? Tangent is opposite over adjacent, right? So that's equal to 440 over 584, right? And then tangent W, 440 over 384. I'm sorry, adjacent. Okay, 384. So opposite over adjacent. So do the same for your tangent W, that's VU over WV. And what do we know about this too? Remember, they are similar triangles, therefore they are proportional. The ratios of their sides should be the same, meaning VU over VW should be equal to 440 over 384. And we can just go ahead and simplify these values with our calculator, and this should give us D. If you have a scientific calculator with you, I'm holding in a sneeze. Excuse me. All right. If you have a scientific calculator, excuse me, and I'm sorry about that. All you have to do is just to key in 440 divided by 384. and then just get the simplified value, and that is 55 over 48. So I hope this helps. Always remember, when you're working with sine, cosine, or tangent on the SAT, you're usually working with a right triangle, especially when it's with a similar triangle. And so rearrange. And how do you confirm? Because we cannot just assume. You can just go ahead and apply the Pythagorean theorem. Use your scientific calculator. What's a Pythagorean theorem again? A squared plus b squared is equal to c squared. So meaning 384 squared plus 440 squared is just equal to 584 squared. And that's about it. I think we're done with, let's just check if we got the right answer. Okay, T. Okay, we're done with this section. And don't worry, if you like the long form, I can go ahead and create more. But if you need more help with specific topics or specific questions, just feel free to comment them down or let me know wherever you're finding this video, and I'll be happy to help you. I also have a lot of resources, so just let me know and I'll happy to send them your way so that you can feel confident and prepared for your next scheduled SAT. All right, I'll see you next video. Bye-bye.